I'm going to show you a quick and easy way to balance a combustion reaction. Combustion reactions tend to be a little bit more difficult than the other reactions because of the ratio of hydrogen atoms to oxygen atoms in it. Let's get started. Here's a typical combustion reaction that involves a hydrocarbon, in this case octane, combined with oxygen to produce carbon dioxide and water. Note here that the products on this side always will tend to be carbon dioxide and water, whereas the reactants will tend to be some type of hydrocarbon, and there are many types, combined with oxygen. Now, in order to balance this particular reaction, we have to understand why we're doing it. Lavoisier wrote years ago that the matter cannot be created nor destroyed, it only changes forms. And the application of that particular law was that the atoms on the reactant side, on this side, have to equal the atoms on the product side. And so what we do is we place numbers in front of the compounds to balance those reactions out. Now these numbers only involve what we call counting numbers, 1, 2, 3, 4, etc. These numbers cannot be fractional, nor can they be decimal. So, in order to balance this equation, we'll go through each individual atom at a time. I always tell students to balance everything out first, then save hydrogen and oxygen for last. So, in this particular reaction, let's look at the carbon first. We have 8 carbons here, and here we only have 1. So we will put an 8 here to balance out the carbons. Now I have 8 carbons and 8 carbon dioxide. Here I have 8 carbons. That balances. Let's go to the hydrogen. I have 18 hydrogen here. Here I have 2. Well, what I usually do is I tell the students, take the total number on one side divided by the other side, and that will give you the coefficient. So 18 here divided by the 2 here will give me 9, and I'll place a 9 in here. So 9 times 2 is 18. 18 here. Go to the oxygen now. I've got 2 oxygens here. However, on this side I've got 8 times 2 is 16, and I've got another 9 plus 9. That's going to give me a total of 25 oxygen. Again, we'll do the same thing. 25 on one side divided by the 2 on this side gives me 12 and a half. So I'm going to put a 12 and a half in here. Now, my equation does balance now, however, I've not followed the rules properly because 12 and a half is not a counting number. It is a fraction. Or you can say it's a decimal as well. So what we're going to go ahead and do is go ahead and change that number to a counting number. Well, because it's 12 and a half, if you know your fractions well, if I multiply 12 and a half by 2, I should get 25. So that would change the 12 and a half to 25. So let's go ahead and multiply that by 2. And it's going to give me 25 oxygen. Now if I do that, if I multiply 2 here, I've got to multiply everything by 2. Now if there's nothing here, it's assumed to be a 1. 1 times 2, or 2 times 1, is 2. CaH18. Plus my 25 oxygens is going to yield. Now I'm going to take the 2 times the 8 and get 16 CO2. Plus I'm going to multiply the 9 times 2 and 18 H2O. Now this should be balanced now, but we want to make sure that it is and check it real quick to make sure that it is. So let's go ahead and look at this real quick. Let's go with the carbon first. Okay, carbon, I've got 2 times 8 is 16. Well, here I have 16 carbons. That balances. Let's go to the hydrogen now. Hydrogen, I've got 2 times 18, which is 36. Hopefully we have the same on the other side. 18 times 2 is 36. So far everything is balancing. Let's go to the oxygen now. Oxygen, I've got 25 times 2 is 50. If I go to the oxygen on this side, I've got 16 times 2 is 32. And I've got 18 times 1 is 18. 32 and 18 is indeed 50. This particular equation does balance, and it's balanced correctly. So here is the finished balanced equation of a combustion reaction using the shortcut. I hope that you can use this somewhere down the road.